Today let's discuss about what? Diffusion, right?
Yes.
And we are saying that diffusion is what?
It's a net movement of molecules from a region of high concentration to a region of low concentration across a semipermeable membrane.
No.
Along
A concentration gradient. For across is for osmosis. So we are saying is the what? Movement of what? Molecules from where? From a region of what? High concentration to a region of what? Of low concentration. Along a concentration what? Gradient. Are we there?
Yes.
Is the movement of what? It should be molecules or even particles from a region of high concentration to the region of what? Low concentration. And we are speaking about what? It should be along a concentration gradient. Along what? A concentration gradient. Then we say we have factors, right? Factors affecting what?
Diffusion.
Factors affecting diffusion. Which are these factors affecting diffusion? Let's read them. Temperature. Second person.
surface area.
Surface area. We have surface what? Area. That
Surface area to volume ratio.
surface area to volume ratio. To volume ratio. Gender. Diffusion gradient. Diffusion what? Gradient. Next.
Size of molecule.
Size of the molecule. Size of what? Molecule. Molecule, right? Next. Type of medium. Type of what? Of medium. Do you have another one? Yes, we still have one. Thickness of the membrane, right? Thickness of what? Thickness of the membrane. Thickness of what? The membrane. The thickness of what? The membrane. Thickness of the membrane. Let's now deal a factor by a factor, right? A factor by what? The factor. Let's deal with a factor at the side. Where is that? White.
That's that.
No, not this one. I carry the tissue. That's a weight. Where is it? Okay. Let me improvise as we wait for that. Let's start with the temperature. We start with what? Temperature. Who will explain us to us about the temperature? How are we explaining about the temperature?
Yes. Increase in temperature increases the energy content of the molecules.
Kinetic
Kinetic energy.
energy.
For making the solid molecules to move faster, hence breaking them.
And it's faster rate of diffusion. That's it. High temperature, we're saying what? We speak about increase in what?
Temperature.
Temperature. What happens? It increases what?
Kinetic energy.
Kinetic energy, right? And when we increase this kinetic energy, what happens? And increase in the emission. Is that clear? And what is happening here? We are speaking about when you increase the temperature, there is increase in the kinetic energy, right? And because of this, when we speak about the molecule, the molecules will do what? The molecule will be fastly dispersed.
Yes.
Because of that, what? Its energy. Is that clear?
Yes.
So the molecules will be far apart from each other. Then when the decrease will be vice versa of this one. Decrease in temperature, decreases the kinetic energy. So it's about decrease brings about what? Decrease in energy, kinetic energy. Decrease in the kinetic what? Energy, right? And because of this, what happens? Decrease in what? Diffusion, right? We are saying decrease in the temperature decreases the kinetic energy. And I said this one was one of our KCSE questions last year. And they used what? They used a dog, right? A test about the audio. And we said what? Early in the morning, what happens? That smell, that audio was not that intense, right? But at noon, that audio was too high. And we are saying the main reason, early in the morning, the temperatures were low. The kinetic energy between those molecules was still low. And that is why that smell was what? Low. Is that clear? At noon, there was intense increase in what? That smell, right? And the main reason for this one we have said is because of what?
High temperature.
Yeah?
High temperature.
Light energy. Not light energy, the kinetic energy being increased. Let's go to the size of the molecule as our number 2. Size of what? Size of the molecule. We will explain to us size of the molecule.
Small molecules have violent reaction.
No. Try
Small and light.
small and light, not small at all. Small can be 8, right? So it should be what? Small and light molecules. Is that clear? Small and what?
Yeah.
Light molecules will do what? Will diffuse at a faster rate than what? What?
Large and
Large
heavy.
and heavy. Than large and what? So it means the large and heavy molecules, the diffusion rates will be low, or even they may fail to do what? To diffuse. Are you get the point? They might fail to do what? To diffuse. Are we there? Which one? Sawa. Next is which one?
Type of medium.
Type of the medium. Type of what?
Medium.
Type of medium. How do we explain this type of medium?
In diffusion takes place faster in liquids, then followed in gases, then followed by liquids, but does not take place in solids.
We are speaking about, we have three types of medium, right? Which one is our first medium? We have gases, liquids, and solids, right? And we are speaking about the diffusion in what? We are saying gases, diffusion will be what? Will be faster and I will be faster, right? Faster rate of diffusion in gases, followed by liquids, right? And we are saying solids don't what? Do not diffuse. Solids do not what? Diffuse. Solids do not diffuse. Hope that is clear. Solids don't what? Diffuse. Solids don't diffuse. Is that clear? But now we are speaking about gases. Why is gases diffusing at a faster rate?
Because their molecules are loosely packed.
Their molecules are loosely packed, correct, right? Their molecules are what? Loosely packed. Because of this one now, they can easily be dispersed. But for the liquids, their molecules are not that closely packed, and they are not again what? Loosely packed. And that is why it's just what? Moderate. Then these other one, we are speaking about solids. They are very compact. Is that clear? Their molecules are what? Very compact. Is that clear? Which one is the other one? This one is 1, 2, 3. We have number 4, which is what? The surface area. Surface what? Area. Yes. Yeah. Surface area. Surface area. Surface area. Surface area. We have the surface what? The surface area, right? Who will explain to us about the surface area? Yes, surface area. Yes? The larger the surface area, the higher diffusion. These surface are larger surface area. What will be the size of the organism? Small. Small organism, large surface area, right? Small organism what? Large surface area. And hence, faster rate of what? Diffusion. And vice versa, right? So you're speaking here small organisms. How much? A large surface area to volume what? Oh, it's just surface area, right? How about like what? Surface area. Hence, faster what?
Rate of diffusion.
Faster rate of diffusion. I think you understand this is clear, right? So we are saying what? Faster rate of diffusion. What about the larger organism now? It will be opposite, right?
Yes.
The larger the organism, the smaller the surface area. Hence, yeah, they will be reduced. The diffusion rate will be at a slower rate, right? We have now the surface area to volume ratio. Surface what? Surface area to volume ratio. This one is a comparison. Surface area to what? A volume ratio. This one is a what? Is a comparison. What are we comparing here? Surface area with the volume ratio. So it's just still the same thing about surface area. But now you link to the volume ratio. So what do we speak about? Small organisms? Small organisms? How much? We don't speak about big. Larger surface area to volume ratio. Is that clear? And faster or higher rates of diffusion. Is that clear? So we are speaking about what? Small organisms. We are speaking here and vice versa, right? So we are speaking about what? Small organisms. Small organisms are what?
Large surface area to
Large
volume ratio.
surface area to volume ratio. They are what? Large surface area to volume ratio. And faster rate of diffusion. And faster rate of what? Diffusion. And vice versa still. And what? So the vice versa what is what? The larger the organism,
The small
the smaller the surface area to volume ratio. And because of this, what happens? Hence low rate of
diffusion.
hence what? Lower rate of diffusion. Which one is the other factor?
Thickness of the
Thickness of the membrane. Thickness of the membrane. We have those who are not responding the questions. Now I'm going to them right now. From the fair end. How are we explaining about this thickness of a membrane? The thicker the membranes, the slower the rate of diffusion, right? And the what? The thinner the membrane, the faster the rate of diffusion. We say the thickness. The more the thickness, the increase the diffusion distance. And that is why the diffusion rate will be slower. Is that clear? So we are saying thick membrane, thickness of the membrane. Thick membrane, what happens? Increases the what? Diffusion what? Diffusion distance. It will increase what? The diffusion what? Distance. Hence what will happen? Hence slower rate of diffusion. Is that clear?
Yes.
Then we are speaking again about what?
Thin membrane.
Then now the vice versa will be V. Membrane. What happens? Reduce to what?
Reduces the diffusion distance.
Reduces the diffusion distance. Diffusion what? Distance. And because of this, what happens?
Hence lower rate of diffusion.
Hence,
Higher rate.
faster.
Yes, faster.
Rate of what?
And vice versa.
No, there is no vice versa, my friend here. Which vice versa again, and I'll do them both. It will be vice versa. Maybe if I say the first one, I make the second one to be a vice versa, but I've done it, right? So that is it. Those were our factors affecting what?
Diffusion.
Diffusion rates. Exactly.
Yes.
So next we have to check about what? Not osmosis, experiments.
Yes. Experiment.
So we do the what? Experimental section.
Yes.
Thank you for this lesson.